Tutti. All right. Hi, Moein. How are you?
Hi, how are you? I'm fine.
I'm doing good as well. Okay, let's jump into this because as we were just talking with each other, today is gonna be a little bit shorter because of a hard stuff that I have, and I apologize in advance. But we have a couple of links to go through. Do you want to start? Because I know that you have more links, and then every now and then I can jump in between and maybe share one of two of mine.
Yeah, all right. I can share my screen now. You need to give me the permission to do so.
Just 1 second. There you go.
Um, okay, let me see. Okay, can you see this? Is it being shared?
Yeah, I can see that, and that's nice.
Yeah, okay. So I just want to pause a little bit here and just to cover all the things that happened in the last 2 weeks, which were a lot basically. And I'm not sure how much of it we can cover here from the release of lots of models from Google, from Gemma family to the update of the Gemma family to the 2.5 Pro model by Google and the updates of the GPT-4o, the image generation model, the viral images of Ghibli style, and lots of other things that happened in the past 2 weeks. And I'm sure we can cover it all, but we're at least trying to do so. I will start with something not relevant to LLMs or VLMs. I mean, not directly, something more relevant to AI and uh, medicine in specific. And this is this paper from Vector Institute in Canada, in Toronto, I think. And this is a really good work. Basically, every project that tries to somehow release a public data set in the medical domain, I think is really valuable, especially these large scale data sets. And these people, these researchers did the same thing. They scraped many of the papers on the PubMed, those that provided some medical figures. Most of them, or at least maybe one third of them, were in radiology, the images of the papers, and they kind of like filtered this huge data set to make a paired image and text data set out of those papers. And they used GPT-4o and lots of other models downstream to make this available. And just let's see the paper, the abstract here. We introduced OpenPMC, a high-quality medical dataset from PubMed Central, containing 2.2 million image text pairs. And as far as I remember, this dataset was filtered down from a 17 million pool of data. So it's highly fine-grained and filtered, and lots of irrelevant captions and figures are eliminated from that pool. So I think it's a really high quality data set. And we can see the process, how they came up with this model here. This is a distribution. So basically, at least two-thirds of the images are directly medical, with one-third being ambiguous and other. And I didn't check what are the examples of those. And about a third of the whole data set is for radiology, another third is for microscopy, and the other one is probably natural image data set, images like probably maybe lesions on the skin or something. And here is one of the examples in this figure. For example, this image and this caption and the relevant text describing that figure in the main paper is depicted here. And the researchers gave these images and the relevant text and the caption and everything related to that figure to GPT-4o and wanted it to caption it basically to make sub captions for each of these images. And they mentioned that they use object detector models like the ETR from Meta, I think, to crop these images and make separate sub figures. So basically, this one figure of the paper is broken down to multiple sub-figures and with multiple sub-captions. And these make the paired image and text data set, which could be used downstream to train foundation models like CLIP and many others that require image and text. Yeah, here you can see one of the examples how they do this. And yeah, they in the most recent data set comprising 24 million image pairs, I think this was the main pool of the data set, or maybe the biomedical, but they go in details about how they have made this. Yeah, I think for data prepare, this was the actual number of images and pairs they came up with. And then it was filtered down to 2.2 million images. And they also trained a clip model on that, yeah, with a VIT transformer as encoder and biomed clip and a BERT model. I think another BERT model which was trained on PubMed they used as the text encoder, and the trained clip model is also available on the Hugging Face. So yeah, I think this was a good project. I mean, these larger scale data sets, or maybe medium scale these days of AI, 2.2 million is not that much, but is going to be really helpful for making foundational models to do downstream radiology tasks, downstream microscopy tasks, and further research projects. Yeah, this was the first one I wanted to cover. They have also,
So
uh,
before the
yeah,
one question, so I know that there exist a few other medical image text pair data sets as well. I don't remember
yes.
the names of those often.
Yeah, the biomedical, they have introduced them in the related work, I think.
And have they
Yeah.
compared the quality of their models, or I mean any indices of their data set quality with those data sets with the old one?
Yes, and I think the most direct one is this table 2, which compares the retrieval performance, the recall at 200 results. And this is basically the performance of their model trained on their own data sets compared to other clip-like models which could be used for retrieval. And as you see, for many of the tasks, at least, their model is outperforming the others. And in the summary, it is performing the second best results here, probably by a large margin, I think, here.
Yeah,
And,
nice one.
and yeah, yeah, go on.
No, nothing. But I was just saying that's a nice work.
Yeah, definitely. And this is the model that they have open source with all the weights, and it is on Hugging Face, so it should be easy to use. And yeah, I really liked this research and their approach to open sourcing all of their code and models, and the paper describes the whole pipeline really well.
Perfect. Nice work. Thanks for sharing.
Yeah, this was it. And then I will go to probably introduction of Manus AI here.
Okay, yeah.
I think you've seen this
Yeah.
during the last 2 weeks. This was again another AI agent framework, I think, but on the but the users are the public. It's not directly for developers. So it's like we've seen these type of applications in OpenAI, like the deep research that does some background task for you and notifies you when that is ready. And also both OpenAI and Claude have introduced agents that are still in experimental phases, I think, that will be able to go and reserve hotels for you or make some travel plan for you, and you don't need to be at your computer all the time. It can go and make the whole plan ready automatically, and uh, it will come back to you when the results are ready. And with Manus, the idea is the same. The use cases are much more versatile, and there are many in there. They are in many categories. Like, yeah, you can see those examples like the trip to Japan, and also in research, in data analysis. I think this video that they have put here covers the the basic capabilities of their agents very well. And I think it's no point to start watching it here because everyone can do so. But one of the interesting things that they have put in their uh, website is this general AI assistance benchmark, which shows that their agentic model, or I'm not sure how we should describe these applications, agentic AI applications, I'm not sure, is outperforming both OpenAI Deep Research and the other contenders in this area, which is really cool. And again, this is a company in China, so the competitiveness of this field is again was brought to the attention of the public again by the release of this model after the DeepSeek. And yeah, I think and they are going to open source their base model, I think, based on the video. They said that open source community has made all of these progress available, and we want to give back to the community, so we are planning to open source our research as well, which is really interesting. And I think this is not something that OpenAI or Google really like.
Yeah.
Have you had the chance to try it, or did you have an invitation code or something? Because I
I
still have not.
signed up for this in the beginning that it came, but I have not yet received any invitation to start working with that. But I went through some of these videos and they were amazing. I mean, I was just amazed by that specific video that was showing that Manus is controlling many different screens at the same time, and every screen was doing something different than the others. That was very exciting and at the same time kind of scary, to be honest, at how much powerful this entire system could be. And that's fascinating. And but yes, I mean, I'm still waiting to have my hands on this in practice, but no invitation, unfortunately, so far.
Yeah, and one of the examples I remember was the stock pattern matcher or something related to analyzing the stock patterns of some input stocks. And it went on opening tabs and downloading the data related to the stock market on those specific labels. And then started some Python analysis and then uh, put its results and outputs in a spreadsheet and made a website for displaying those results, which was really crazy at how good it could do this all by itself without much output from the human. I think there are some levers or some knobs for the user to intervene or change something when the agent is doing its work. But based on the demo, for that case, it was all by itself, which was really crazy and yeah, scary.
And Moein, something that really caught my eyes, and maybe you have a more accurate information on this, but one thing I heard from a couple of sources was that the backbone model that Manus is using is Cloud 3.5, even not 3.7. But basically, their agentic workflow was the main novelty that they had, and how they put together different agents based on the cloud model behind the scenes. Is that what you heard as well, or have they come up with their own fine-tuned version of these models?
I think the base model is, yes, this Claude model or Gemini. I'm not sure about that, but based on one of the blog posts I was reading by Hugging Face here, that I was going to share that as well. They have also gone a step further and fine-tuned those models, or at least maybe a version of them, because I don't think they have access to the source
Cloud is not
models.
first.
Um, yeah, to basically make them work with this agentic workflow like the way they want. And I think they have mentioned the word fine-tuning, but I'm not sure how they have done that
Yeah.
on those closed models. Maybe, I don't know, maybe they have a second model that is interacting with those models, and that is fine-tuned for agentic interactions. I'm not sure. But yeah, it leverages large language models, multimodal processing, and tool integration. And it's one of the highlights here. Let's see, yeah. And this is the on the performance on the this Gaia leaderboard, which as we can see here, is probably doing the state of the art compared to the contenders here, more than 65%, which I think is it should be a high number based on that these benchmarks are really hard these days. And yeah, it's still we don't have many technical details about this model and this approach, but based on that demo and this blog post, I think we could have just a basic understanding that most of their effort was on making this agentic workflows like basically what Cursor, for example, is doing on the software side and development. I think they're doing for more public tasks, more the tasks that public would be interested in. So yeah, I think these LLMs are kind of like commodity these days. They are replaceable, but the layers that could be built on them is going to be the value that these companies bring to the market.
I agree. I agree. And I believe since the last time we spoke, also the OpenAI Agentic SDK came to the market, which is again something open source. And the good thing, as we were just talking about it, is that it supports both model context protocol from MCP, which is becoming more and more widespread every day, and also the Gemini family of models. So basically a nice stack, at least in my eyes at the moment, the best multi-agentic stack that somebody could come up with if you are not working with something this production ready as Manus is your own workflow based on OpenAI SDK using tools that are connected to MCP, and on the other end having Gemini and OpenAI family of models working together. I guess we are going to see much more about agents as we go forward, and I guess this is just the beginning. But even the beginning looks already very scary. I mean, Manus, to be honest, has scared the shit out of me when it came out in the first place.
Yeah, and well, I think I saw on Twitter that people were discussing that it's not far-sighted that we will soon have very expensive pricing plans like $200 a month, like we have for OpenAI Pro, and I think OpenAI is also considering a 2000 pricing plan to be released, and if we have such capable models that could do PhD levels research programs or do these complicated tasks on their own. I think there are enough people that would spend that much of money to just automate all their tasks if the quality is good and it doesn't disappoint them.
Yeah,
And I think, yeah, the future of these companies will more rely on these sorts of income than like cheaper plans like the $20 a month that they have currently.
definitely, definitely. Let's wait to see what comes out of it, but very exciting time.
Yeah, so I can stop here if you want to jump in,
Yeah,
and then we can continue.
sure, sure. So let me share a couple of things here. Let's start by one of the things that I like a lot. If I can find the uh, paper here. There we go. Okay. So let me share my screen. And here we are. All right. Are you seeing my screen now?
Yes.
Okay, so I'm going to start with one of the papers. Then, when it came out, it really caught my mind, and it was titled "TextGrad: Automatic Differentiation via Text." So the idea behind this paper is very interesting, and the paper also has a publication on Nature. Unfortunately, it's not free, so people might have access to that to go through it, but they have a very nice website as well, which explains everything. The idea behind TextGrad is very interesting. They're saying that, similar to how gradient descent works, we put together a system that is going to optimize an underlying model, an underlying deep learning model, using textual feedback out of an LLM's mouth. So, and this diagram here is kind of interesting. They're saying that, hey, if the input is, for example, an image, in TextGrad, the input could be maybe an article, an entire article. And instead of having a ResNet 50 in a normal PyTorch in a traditional deep learning training framework, now here you have an LLM, which could be any black box LLM that you just want to fine tune or maybe further train. And the loss is going to be something like, text loss. And that is going to be equivalent to the old cross entropy loss here. And the way that it works is that basically they are asking an LLM to rate the quality of the answer of this black box LLM. And then somehow, depending on how much the rating is getting higher or lower, the feedback is being translated into changing the model weights of the black box LLM. So this is how they are doing that. And it's very similar to PyTorch. They basically mentioned that if you know how to train a model using PyTorch, you already know how to train a model using TextGrad. And they have a loss function, they have a backward, they have optimizer, they have everything. And very nicely, this entire package is already available for you if you want to play with that. And the code is going to be as simple as this one. Say, for example, you have a TextGrad package imported. You can just set a backward engine, which is going to be a GPT-4o, and then you come up with a black box LLM. You give it a question, and then based on that, define a variable, and then you can have the model to answer your question. And the next step is that now that you have it, you can go ahead and try to optimize this one, right? So, for example, you can say that, hey, try to optimize this response for me in a way that it increases the rating and it goes forward and runs the back propagation and optimization to an extent that your answer becomes better and better as we go forward. And it is a very nice trick for problems that have more concrete solutions, such as math and coding, as is the case with reinforcement learning. So they do it here, and again, depending on the model's response, they calculate a loss and then they can run the backward and then see how the model performance improves over time. So it's a very nice I see it as an online reinforcement learning. So basically, they are, again, aligning the model somehow towards a desired response, but a very nice trick. And the fact that it is very similar to uh, basically gradient descent is very exciting because now we can have lots of analogies here regarding how we optimize gradient descent, and maybe we can be able to apply it here. So similar to how these vibe coding tricks are changing the way that we coded. It seems that now we will have more and more explicit ways of training our models or fine-tuning our models as well, rather than dealing with this values and black box numbers that are difficult to interpret. Maybe we can have everything be formulated as text, and this will shed a lot of light on the black box of explainability of these models as well. So this is a nice paper and a nice toolkit that I just wanted to introduce. So for those who are interested, they might go through their website and they have lots of examples that they can take a look at. And I guess it's a very inspirational piece of work as well.
Yeah, that was really interesting and novel idea. I just had a question like that for the evaluation, like the text loss. I think a separate model should be used for the evaluation. Am I right? I don't think the same model could be used
Yeah.
for evaluating its own response. What do you think about it?
I think the same. I believe what they have done in this example is that they basically used two different GPT-4o instances. That's what comes to my mind. But let's go through it and see.
Yeah, and it could be the same family of model, but I mean,
Two
the
different-
model that is being updated cannot be the model that is evaluating, because
That doesn't make
uh, I don't know, maybe that is possible as well, but it makes more sense to me if the evaluator model is a separate model which is not being updated at each step.
I totally agree, and I believe that makes a lot of sense. Apparently, you can use this one maybe for tuning the responses of a weaker LLM, which is much, much cheaper, using an LLM that is more expensive, and you want to use it sparingly, maybe in order to teach the cheaper model what to do and what not to do. So what you say makes complete sense to me, and I believe that's what they intended to do as well, but probably not the most uh, clear examples are presented here.
And do you know how they propagate the final signal. Like for example, the loss says, okay, this is a good summary and gives a high. No, let's say the evaluator gives it a low number and says, okay, this summary is not good. How they propagate this signal to each individual weight of the model to get updated, because in the SGD, or basically how these models are trained in deep learning, uh, by calculating the gradient of the loss, you effectively have the gradient of each parameter. But when you're doing it using text, how do they propagate this into numerical numbers to change the each individual weight?
Well, I am not 100% certain because I couldn't go through. Unfortunately, these nature barriers are difficult to access to, and I am away from my institutional access at the moment. But what came to my mind when I was going through their website is that they are basically using a scoring function. So if you see here, this diagram here is saying that your job is to rate the summary. So I believe they're trying to come up with a numerical representation of how good the model did in the
Yeah.
performance, and then based on that, try to back propagate to the weights and go towards a better performance. So they are trying to somehow quantify the model's performance using the supervising LLM.
Mhm.
That's
Okay.
yeah. Well, let's see if we can find the uh, so the source code probably has a very nice one. Maybe the paper, let's see if at least in the app. Oh, okay. So the archive paper is ready. I didn't see this one. Now it's the first time that I'm seeing the full text. So let's look at this diagram together and see what we can get out of it. Okay. And then
I
TextGrad
think
molecule optimization. There we go.
I think the first panel or was showing that in, yeah, for the on the right side, I think they're showing their approach. It says that the LLM gives the loss
Yeah. And then it goes to,
and how. Oh, as you see, the signal is also being propagated using text. As you see, this response can be improved by. So it's like everything is being done
yeah,
using text. Maybe I'm not sure. Maybe the weights aren't changing here, and maybe the prompts are being updated.
that's interesting. So basically, this could be a prompt optimizer package rather than a model optimizer package.
But in the table, you see that it is listing the model parameters and
That's
the TG.TGP.
that's
Yeah.
what I saw as well.
So
Maybe if the model is open source, they can play with the weights as well.
yeah. But this is really, I mean, one of those research papers that is definitely in its own league.
Yeah,
It's an improvement on some other method that was introduced some years ago. This is introducing a whole new idea, and this is really interesting. I will go through it in more details to
yeah,
find out how it works.
yeah. I mean, definitely, I agree with that. So maybe we can take a look at here. So the example optimizer. So in a standard gradient descent, the current value of the variable is combined with the gradient through subtraction, which makes sense. Continuing the gradient descent optimization analogy, we use textual gradient descent, which basically means that the new prompt, so here they are updating the prompt, is the textual gradient descent dot step the current prompt and the evaluation based on the prompt. This makes sense, but again, your question is still valid. Why did they mention updating the weights in their first diagram? Uh,
Yeah, if the prompts are being updated, that makes total sense, and I think that is doable. And I think the code is also easy to implement it. It shouldn't be that difficult. But yeah, I'm not sure why they mention the model parameters in that table.
yeah, we should probably go through this and try to clarify this a little more, but uh, again,
Yeah, the variable is still the question. You see
yeah.
on the code.
This one?
Yeah. the as you see the solution variable, the zero shot LLM with the question. So it's basically taking the prompts. I'm not sure, but this looks like a really interesting paper.
Very interesting paper. And I mean, the entire idea of applying textual gradient descent either to optimizing the prompt or optimizing the weights is very interesting. I mean, to my very primitive understanding here, if they are dealing with open source models, I don't see why they should not be able to translate the scores of the of ultimate model to the weights of that open source model as well, because as far as you have some numerical evaluation uh, of the model's performance, you might be able to walk towards optimizing that score. So maybe the
Yes, if they incorporate an RL kind of like module, they
yeah.
can do that because yes, the loss basically works like a reward system. So if it gives it a high reward, the model is prompted somehow to repeat its behavior, and if it's a really low score, it learns to change its behavior somehow so that the score gets higher. But I'm not sure if they're using RL in this process because in the title and the code here, I'm not seeing mentions of any RL module.
Now that I saw this code snippet, I believe that's basically optimizing the prompt. And I guess what is causing the confusion is that if you look at this line, they
Yeah,
are
the parameters are the system prompt.
of their optimizer, but they're feeding to that the system prompt. So I believe they just wanted to mimic the vocabulary
Mhm.
of the traditional gradient descent and training schemas, and they called whatever their optimizer receives as parameters, whereas what they actually meant was that they are feeding in the system prompt. And now, if you look at this comment here, they're basically optimizing the system prompt. And optimizer, the only input to that is the system prompt. So what they're doing is that, and I guess it's still valuable and it's still interesting, that they are trying to, for example, put together an initial system prompt for a model that needs to do something, and then maybe give it 100 different examples, maybe evaluate and score the responses that the model gives back, say, for example, using a more expensive, more capable model, and then through multiple iterations, optimize the system prompt for that, experimental model, which could be the weaker, more efficient one, towards an optimal performance. So it's just trying to come up with a good system prompt for a given model for a given task. That's what I understand now.
Yeah, that makes sense. And I think we can also come to the same conclusion, considering that they were using GPT-4o, and there is no way that they could change the weights of the GPT-4o because they don't have access to them. So they're basically optimizing the prompts. And I was thinking like maybe the next level of programming and optimization is basically making a random framework for an agentic system with, for example, with random rubbish text as the prompts of each of the agents, and then train this whole framework of agents, which are each of them have access to some LLM, um, evaluating it with a final reward, which the gradient is back propagated via text. And I'm not sure if I've
Oh,
clearly
I
conveyed what I meant,
yeah.
but I think this could be the next level of programming and optimizing these big kind of like neural networks.
I agree. So if you remember, we also had a field that is probably nobody thinking of it nowadays, but it was called neural network search, something like that, neural architecture.
Neural search, I think, which was for coming up with optimizing the architectures of the models. Yeah.
Yeah. And now you can think of the same sort of research on optimizing the setup of agentic frameworks. Say, for example, if you want to do a certain task, how many agents should you have? What tasks should these different agents have? How should they interact with each other? And basically, that's now a more of a system optimization task rather than coming up with a
Exactly.
prompt optimization or weight optimization task. And that could be the next level. So we started from weight optimization. came towards prompt optimization, and now the next level might be the system optimization, which is very interesting.
Yeah, and if you think about the data sets that could be used for training such systems, the dataset is much higher level. The dataset is basically a task and a final results, for example, for the task. For example, the task could be write a paper on that topic, and the ground truth for that is basically a made up or a really human generated article with the initial prompt. And then that system should be optimized in a way with fine-tuning all the prompts in there and all the agentic framework, when to stop these API calls and everything to come up as with a paper as close as to the ground truth paper. So the data sets are getting updated as well. And I think really that was a really interesting insight out of this conversation
Yeah.
that maybe really the next level of optimizing and programming is on this side.
I agree. I agree. And I believe, to be honest, the way that it should be done, it's similar how to this paper is optimizing the prompt because again, you are optimizing some sort of textual instructions, and even it is going to be more straightforward than optimizing unstructured text because you can just come up with some notations. Designing an algorithmic system of agents that are interacting with each other is not that difficult, so you can come up with your own
Yeah.
arsenal of tools and maybe arsenal of communication schemas between different agents. And then in your example, you just can give it, a final article, and then maybe you can say that, hey, the initial task is that I want to come up with an article that has these properties, and we already have millions of articles that are already published and have very good qualities. So we can just force the framework to start coming up with the best practice that you can use together to come up with something similar to the ground truth paper. And then again, back propagate towards the agentic design and make the design better and better step by step so as you can come up with better papers. I guess this is something very interesting to do, or at least try in a research study.
Yeah, definitely. And here the hyperparameters, I mean, the prompts are one of the hyperparameters. There are lots of other hyperparameters in such a system, like which LLMs to use, which LLMs these agents should be basically relying on,
Yeah.
and how many API calls, and what is the halting process, when to stop these calls, and I mean, lots of things could be evaluated, and the hyperparameters of such a system, I think, are much more complicated than the hyperparameters of a deep learning architecture. But it's a really interesting thought process, yeah.
Definitely, definitely. Anyhow, yeah, so sorry for the initial confusion about this paper, but I'm happy that
Yeah,
we
it
came
was
with
very interesting.
some nice conclusions at the end. All right, so let me quickly walk you through another paper that I wanted to share with you. And this is, let's see. So this one is, I already shared that with you
Yeah.
yesterday, so I just gonna very quickly mention this here. This is a nice paper named BizGen, I guess, Advanced Article Level Visual Text Rendering for Infographics Generation. Uh, I mean, we can jump into the details of this paper, but to be honest, not that important. What really matters here is to just take a look at these infographics and keep in mind that these are all AI generated. So I believe we are entering an era that many of the efforts that our generation put together for creating a slides like this, infographics like this, working hours and hours on presentations to be given in conferences, are going to not needed anymore. So this is a very nice paper that is going to design that has designed in a specific model, a fine-tuned model that can come up with infographics and slides like that. Not something that I want to stop too long on because I have more things to share, but just wanted to let everyone know and introduce this example paper that the newer generation of models that are coming are basically going towards be very specific for use cases like infographic and slide generations. And then they are going to be super, super handy for academic purposes and many commercial purposes as well. And
Mhm.
I believe they have the code available. As far as I understand, their model is also accessible on Hugging Face, even though you might need to have some GPUs available. But
Uh,
we can look at it. Is that the case? Have they released their model?
I haven't looked at whether they have released their model, but I had a question about the architecture. Is it a diffusion model or is it some VLM or something?
So to be honest, I
I
believe,
saw Flux somewhere in the abstract, so I thought it's probably a diffusion model.
yeah. So let's go here. I guess we can see the. Yeah, it looks like to be. What I remember from the paper was the idea of using cross attention in a guided manner, but now it seems that it's a diffusion model because if you look at it, they have an input infographic. They encode
Yeah, the latent diffusion model there.
latent diffusion model goes there. And I believe what they have done that has resulted in this nice output is that they are using a specific kind of cross attention and then region prompts. So basically, now I remember. So basically, they processed individual prompts for different parts of the infographic. What they did was that they took that ground truth infographic, processed that in a way that so somehow they broke it into multiple parts, came up with prompts for every single part of it, and then feed those prompts as input to the diffusion model and task the diffusion model to rely on those input prompts to come up with that exact infographic, which makes a lot of sense. And I guess then they came up with those nice outputs. But yeah, that's behind the scene. A very nice diffusion model, and they have used GPT-4o for coming up with those region prompts, as I mentioned, and then some clip model behind the scene, and then a specific kind of cross attention.
And this is really interesting that they have been able to do this with this using multiple different modules from many years of AI research and coming up with this complicated architecture. But these days, every time I see these complicated architectures, I automatically think that, okay, in the next few months, there's probably these big LLMs will be doing this just by getting trained on a large data set of these things. And as we have seen with the update to the GPT-4o, one of the things that really went viral, I mean, beside the Ghibli style images, was the infographics. They weren't as complicated or as good looking as these ones, but I think as everything with AI, this is the first step, and the next version of GPT-4o or any of these big LLM, VLM, autoregressive transformer models will probably be good at doing this as well. And also, we know that the this new feature in GPT-4o also uses diffusion models, so it's not just autoregressive. But I think the overall structure or hierarchy of the modules in their overall architecture is probably simpler, but their gain comes from being trained on a huge data set.
Yeah, I agree. I agree. And I believe so. I'm not sure if diffusion models are going to be off the radar of the game as we go forward, but I think at least autoregressive models showed lots of promise with this GPT-4o new model that came out, even though it is still somehow dependent on diffusion models. But at least we showed that, autoregression can still do lots of magic that we have not yet seen. And that's very interesting. I mean, that's just basically very impressive to see how impactful one simple architecture that came in 2015 has been after a few years, and how much magic is being created using transformers. So this is something to have an eye on. I think at one point in history, when a Nobel Prize will go to authors of transformers.
I really hope so. And they were really close. I mean, Anthropic, sorry, the DeepMind and the AlphaFold won the Nobel Prize for their work on the protein structure prediction. But I think the Transformer authors really deserve one as well.
I believe as we go forward, maybe because I guess the trend that Noble has is that they wait a few years or even maybe
Yes.
1 or 2 decades to make sure that a piece of work is profoundly impactful. And then if it is, then they are going to value the work of those developers. And I believe Transformer is going towards that direction. So somehow,
Yeah, it has really successfully passed the test of time, I think.
yeah, yeah. Anyhow,
And
yes,
yeah, I have something to share related to this idea, and that was this conversation reminded me of the Bitter Lesson by Richard Sutton,
okay.
who won the Turing Award this year. And I think I've shared that with you earlier, maybe a few months back, but I can share with his
Let me
um,
stop sharing.
post, I think. Let me see. Um, yeah, I think here it should be accessible. It's funny that the website of the Turing Award winner is down, but there is a version of that available somewhere else, and I'm going to share that.
Okay.
This is the a well-known blog post by Richard Sutton in 2019 about the bitter lesson, and the general idea is that in research of AI and probably before that in software engineering, the first approach that comes to minds of the researchers is that they go and come up with a complicated and manual process to come up with the results. And it mentions how the chess was solved before deep learning using the I don't know what was the name back then, the Deep Blue, I think. It
Yeah,
wasn't deep learning, but the name was Deep Blue that defeated Kasparov in chess. And it was using search and using lots of handwritten code, which was basically an if-else kind of like scenario. And as we got access to much more compute and better architectures, we found that we don't need to design those architectures by hand, and we can just train a model on huge data sets without much intervention, like what the AlphaGo and the models by DeepMind that was developed to perform chess and Go game did, and they were able to achieve much more impressive results by just using gradient descent, which doesn't write any program or any if and else statements. And I think, and this is the bitter lesson that he says the researchers should learn. But I think this is just on the philosophical level. We cannot jump into that direction to that final good architecture like transformer or deep learning itself without going through the process of designing first the first modules by hand and then trying to train an end-to-end pipeline. So I think this is happening here as well. Lots of narrow AI models are coming up. They themselves are using transformers and we call them narrow, but finally, a really huge model, a huge transformer, basically trained autoregressively on a huge data set of images and text, probably learns to do that task like this infographics by just seeing lots of examples like that and probably much better training pipelines.
exactly.
But yeah, this was and this is known as the bitter lesson in AI. This is just a philosophical concept, probably to have in mind that probably many of these complicated codes, complicated architectures that we are seeing these days will probably be are going to be trained in an end-to-end simpler manner, but using much more compute and much more data in future. But if we don't have these examples right now, I'm not sure how we can come up with those final results. And I think this was um, the result of a conversation we had earlier on this topic.
I agree, I agree. And I think Moein, science itself is going through it's going through a gradient descent type of exploration. So, we also do a lot of try and errors, move towards the direction that finally we will go through, and sometimes take a few steps back, maybe explore other directions, figure out that those directions are not working, come back and then try a new door. So I agree. That beta lesson is true, but the thing is that there is no better way for achieving that. We need to explore different ways. Sometimes you need to build a dummy product of a for a nice purpose, and then as the time goes on, somebody will come back and figure out a more mature product and can achieve that purpose. So yeah, this paper itself is showing a complicated process for achieving an infographic or a slide set. As you said, maybe in 2 or 3 months, the next version of GPT-4o, you can basically describe your prompt and it comes out of it with a nice infographic. And I guess you and I were talking about neural style transfer as well the other day. That's what GPT-4o new image generation model is doing at this time. So basically, you just give your image to that, give the desired style, and it single shots the output for you in a very high quality. About 2 years ago, there was an entire area of research and paper with just publishing Medium blog posts about that, and everybody very liked those blog posts. They were doing this magical process named neural style transfer, whereas they basically trained one model or to or use gradient descent and gradient ascent behind the scene to come from one style to another. All of that without all of those hard engineering can now be done using one simple LLM. So yeah,
Yeah.
I guess that's the general direction for all the things that we are interested in nowadays. Someday later they will be automated.
And I just remembered that we needed to train separate models for transferring the style of Picasso, for example, and another model for transferring the style of another artist. And now it now really looks funny that one LLM, which is basically trained on the whole internet and many more things that are not even on the internet, can also and can do these tasks just with gradient descent on the background and transformer and autoregressive training. Yeah, it's really interesting.
That's a very interesting one. That's a very interesting one. All right, now that you have the wheels, feel free to go ahead and share another
Yeah.
interesting
So
that you
the
have.
other things I wanted to share was, yeah, a quick mention of the Gemma family, which I'm really a big fan of.
Mhm.
They're really a small, I mean, compared to the other LLMs we have these days, are small LLMs that could be fit on a single GPU, which is crazy, and they're really performing very well on the leaderboard. So I think the 27 billion, which is still could be fit on a single GPU, is one of the top 10 LLMs on the LLM sys arena, I think, which is really interesting.
Moein, a question.
Or one there, yeah.
Have you used these Gemma models?
You can use them in the AI Studio by Google or Olama, and all of them work.
No, have you?
I think the easiest is the Olama. I don't have um, enough RAM to have these 27 billion, but I've installed the 1 billion model, the 1 billion parameter model, and it really works really well. And I think having these LLMs locally is really helpful because if you think of some doomsday that there is no internet or no electricity, it's really good to have something on your laptop with the final percentages of your battery to find out some things about the world.
So I went ahead and played a little bit with two versions of this, the 12 billion and 27 billion. Obviously, both of those were Q quantized up to 4 bits, but still very amazing performance. I mean, the Q27 still runs a little bit slow, so it's basically just taking all that power out of my laptop. But the Q12 is fast, is reliable, is nice, and I really like it. I mean, yeah, this Gemini family of models are state of the art, but for most use cases, proofreading an email, doing this, doing that, why do you need this? I mean, you just have a Gemma model on your laptop that is even very safe. It is quiet, basically, if you are dealing with HIPAA, this is quiet, HIPAA safe, and then you can do everything that you like with that. So, uh,
Yeah. And also, other than the 1 billion model, the 4 billion, 12 billion, and 27 billion are multimodal. So they can also comprehend images. And yeah, it's really interesting that you can have such powerful models on your laptop and they work. I think the 1 billion on my MacBook Air really works fast. So that is really interesting. I've not tried the 4 billion, but I think I can't try the other ones because they need lots of RAM and I don't have that much.
okay.
So this was one thing. I think not this one. I wanted to share the introduction of the GPT-4o by OpenAI. Uh, let's see, image. Yeah, this one. And I think everyone has seen this probably because it went really viral. But just thinking that this image is AI generated is crazy. And yeah, I wasn't believing this until I saw the prompter. And yeah, this was also a really cool blog post by OpenAI. And I think one of the examples I really liked was when the model was used to um, basically an HTML code was given to the model, and the model was prompted to make an image of how this HTML code looks when it's rendered. So it didn't have access to some HTML render or something. It just needed to see the code and imagine how the pixels
That's
would look like.
that's really
And yeah, this one, the code generated image. Here is the HTML, and this is given to the GPT-4 on prompt. And yeah, here is the output of the model creating an image of how it thinks it looks when it's rendered. I think this is really interesting how these models are capable to understand both the text tokens, the code tokens, basically, and also the image tokens. And as I think the most information we have about the architecture of this model is the text written on this blackboard, basically, which the model is using transformer and diffusion somehow, and the whole integrated distribution of text and pixels and sound. I think we still don't have access to the sound model is being optimized, and they are being trained in an autoregressive manner. But I don't think any other information about the details of training is being published any soon. So yeah, this was this one. I wanted also to introduce some person here, Simon Willison. He's the creator of Django, which is the Python framework to create websites and many other capabilities that that library has. And he's a really I mean, he's a crazy developer, and he's very productive. Anytime I see his blog post, he has been experimenting with lots of tools, and he has already written lots of blog posts about his experiences, for example, with Gemma, with Gemini new releases. And here he explained how he uses LLMs to help write code. And I found it really interesting, the points mentioned there. And he's a really good and expert user of these LLMs to write code. And there are some excerpts from here that are interesting. I'm not going through them, but this was just, I wanted to introduce this person so that if anyone is interested, they can follow his own blog post, his own blog, which is not this one. This is the Substack that is kind of like a summary of his recent blogs on his own blog. And his own website is much more updated than this one. And here he also listed a few tools that he has developed using Claude. I mean, all of them are created using only Claude, using the artifacts. And for example, one of them is this OCR tool. And this tool runs entirely in your browser. So you upload an PDF and it OCRs it. And this is all being done in JavaScript and HTML, which is really interesting. So, and you can see the whole list of his
wow.
tools here. And I reproduced one of his tools, this Gina Reader. Um, he came up with a simple way just to extract the content of a website using this Gina API, which basically you call the URL of a website with a few characters ahead of it, and then the content is given to you in Markdown. So it could be run using JavaScript and HTML. You don't need a server, so it could be a single HTML file. and the Claude wrote that in the first try, and he's serving it here. I did the same thing in Cursor, and I hosted it using Vercel because Claude somehow wasn't able to do that for me. And yeah, I think these are, and this is a really good, easy list of tools that anyone can try their to see what are the capabilities of these models, what APIs are available these days that make many things possible that you don't need to do by hand, like this OCR thing.
Very nice.
And yeah, for each of these tools, both the prompts to Claude and the generated codes are available, and all of the codes are hosted on his GitHub. So he's a really good educator also in this area. I mean, maybe he's not a good educator in the sense that um, he can go through topics really easily for the public audience, but everything he does is public. So if everyone is interested, they can go themselves in depth and find out how to do something by themselves. And yeah, this was one thing I wanted to introduce in this episode. So yeah, this is it. You can take it from here if you want to share something.
Thank you. Yeah, I really enjoyed the title of the first blog post you showed. I really want to see how this guy is actually using these AI models for coding, for vibe coding. I believe it's a very black box, and I was just quickly going through the lines that he had written there, and I found the line that he was saying that this is very unintuitive and difficult, and I cannot agree more with him, to be honest. It's very interesting the moment that you can put together a demo product using these vibe coding um, workflows. It's very exciting. But the moment that you really want to keep adding features to them, make them a little bit more mature, make them more production ready, make them feel a little bit more real, then you start to realize that things can easily get complicated. And then because you cannot understand what the code, I mean, what code has been generated in prior, and sometimes the code is being generated using syntaxes and commands that you are not that familiar with. Now, debugging things are going to be much more difficult. And now, when you ask these LLMs to go back and revise things for you, things can easily go south. So I agree with him on that part, but probably him and people like him have very good use cases of how to optimize the vibe coding workflow. So thanks.
Yeah.
Uh,
So
yeah, so let me quickly introduce a few things, and then if you don't mind, we probably can call it a day because unfortunately I need to go and start a night float call. Otherwise, I would be very happy to stay the entire night here and go through these topics. You know that how much interesting these things are for me, much more than medicine itself. But let's take a look at a few other things that I have here to share with you. And then I want to show a few things. First thing is that this nice paper that I saw last night, and it's a randomized clinical trial published in New England Journal of Medicine AI that is basically exploring the role of generative AI as therapist chatbots. So, you know that nowadays, most of the young generation, I mean, an old generation as well, basically everyone is becoming more and more familiar with the values of receiving therapy for, different periods of life and even as a regular good practice, and this paper is exploring in a controlled manner how generative AI could be used as therapist for you. And I believe this is a very nice and very easy to read paper. And if you just take a look at the results, even on the abstract, this is very clear. So basically, they just did a national randomized control trial of 210 adults with clinically significant symptoms of major depressive disorder, general anxiety disorder, or clinically high risk for feeding and eating disorders. And then participants were randomly assigned to a 4 week terabyte intervention or waitlist control. So basically, two groups, one group of which received no intervention, the other had a chance to interact with this generative AI chatbot. And so basically, uh, after this entire interaction were over, they were evaluated with respect to multiple different psychiatric criteria. And then Trabot users, meaning that group of users that had that interaction with the chatbot, showed significantly greater reductions in symptom of MDD, which is the depression. And you can see the details of the reduction and the effect size here as well. GAD, which is the anxiety, and CHRFED, which, if I am not wrong, is clinically high risk for feeding and eating disorders. So basically, the group that went through the therapy now is showing clinically significant better outcomes. Relative to controls at post-intervention and follow-up. Therabot was well utilized, average use case above 6 hours, and participants rated the therapeutic alliance as comparable to that of human therapists. So this is kind of crazy. This is showing that, beyond the advertised use cases and what we imagine when we think of movies like Her and things like that, you really can use these chatbots as nice psychiatric companions, as nice psychiatric resources. And they basically said that, I believe somewhere in the article they mentioned that we don't mean that this chatbot is going to replace human psychologists or psychiatrists, but what they were trying to achieve and what they were trying to formulate was that we have a huge gap between how much of therapy services are needed in different societies, especially less advanced societies, and how much therapist workforce we have available. I mean, real human therapists. And they were saying that what we have targeted using our model is that we want the majority of the people who are not receiving any therapy service because they have not access to those can receive therapy service via a very cheap generative AI-based application. And then they have shown that even that application could result in better clinical outcomes. And I think this is huge. I really liked the paper and I really enjoyed the workflow. And that really made me pause because I remember, again, as another old idea that time proved that wrong. 2 or 3 years ago, people were saying that, or even more newer than that. I mean, the initial months that ChatGPT came to existence, people were saying that, yes, these models might replace some traditions, some occupations, even some medical professions, maybe radiology at the forefront, maybe pathology at the forefront, but we have internal medicine, we have psychiatry, we have psychology, and those disciplines are so deep and so complicated that certainly no artificial entity could compete with humans in the performance in those areas. And now, as we can see, here we are, and chatbot agents are proved to be very nice therapeutic agents that can help actual patients. So I pause here. That was a very nice paper that I wanted to share with you. Moin, if you have anything to say about this, I would happy to hear it.
No, I mean this is I agree, really crazy, and I'm really happy that RCTs are being done in this field as well, which is I think the only way you can prove to the academics that these things really work. These are not science fiction. Then this could be applied, and your prior biases against these artificial systems are going to be wrong. And I hope that people get the signal here that this could probably be applied in any other field of medicine, and nothing is safe, and nothing is going to be guarded against these AI models. They're intelligent entities, and they can do many of the intelligent processes that we humans do, and there's nothing wrong with that. And yeah, I mean, the prospect that it promises that people who cannot have access to actual human therapy can have such systems which are probably much cheaper than actual psychiatrist visits is really promising. And I hope it really helps and improves the overall well-being of the society.
Exactly. And I think that's the case for many other medical specialties as well.
Exactly.
I believe long before we think of AI replacing any medical profession or any medical domain, we have huge gaps all around the world and huge shortage in expert medical professions all over the world that AI can fill that gap. And we can have now places that can have access to radiology interpreter agents, where if they do not, then they will not have access to any radiologist on the other hand. And I guess those gaps will be addressed first before we come into thinking about whether or not the current radiologist workflow, pathologist workflow, any physician workflow, or any other professions workflow are going to be replaced. So obviously, these new solutions, cheap solutions are going to address the most burning needs in the first place. And then afterwards, yes, all professions, all industries might also change one way or another, but we have still work to do till we get there. Uh,
Yeah,
yeah.
interesting.
So I would like to pause here, Moein. I had another paper that I wanted to share with everybody. That was this one, The Future of Radiology, the Path Towards Multimodal AI and Super Diagnostics. That was one of the nice editorials that I had read about the future of radiology for a long time, but I don't want to rush through it. So if you don't mind, I will put it on the top of my article list for the next session so that the
Yes,
next time
definitely.
that we sit together, I can introduce this paper a little bit more patiently, hopefully after the night float calls are over for both you and I. And then we can talk with a little bit more time about this. And the TxGemma family of models, another
Yeah, those
nice
are really
model.
interesting family of models. Yeah.
So this one, let's maybe in 1 minute talk about that because I think that by the time that we are going to come back together, more models like this might have come up. So TxGemma is actually a family of open source models from Google, as the name implies, based on the Gemma family of models, which you just introduced, Moin. And so they are not single task models. They are focused to help with multiple different tasks that are from the classification family, for example, to classify whether a molecule can cross the blood-brain barrier or not, regression to predict the drug's binding affinity, for example, and generation, for example, to given a product of some reaction, generate the reaction set. So they put together a family of models based on Gemma 2 and not even Gemma 3 using 7 million training examples and open source that for the familiarity. And again, 2 billion, 9 billion, 27 billion family of parameters, and very nice models to have an eye on. And I believe all of these models are available on Hugging Face. There are nice Colab notebooks here from the developers from Google that show how to fine tune these models for your own workforces or use cases. So a very nice family of models for people who are looking for biology or even some medical use cases. You can just go and try these new models and try to play with those a little bit and see how powerful they are. And I would like to highlight Dr. Aziz's name here as again a very nice no branch of work by her team here. Have you seen these? Do you have anything to add to this?
No, just saw and read the blog post and was really, I think this task is really interesting for those working on, as they mentioned, for drug discovery. And I saw that people were really happy with the Google Colabs as well because they were really detailed and helped them understand how they work.
Yeah,
And yes, I mean, they're really easy to use. They're on Hugging Face, so there shouldn't be anything hard to load them and work with them.
yeah.
And yeah, it's really interesting days that such models, such interesting and complicated tasks could be easily done in some Colab notebooks.
Exactly. And Moin, I guess this is how the era of training models from scratch will change if we are going to change the weights of any model in the first place. Because most of the time we might end up using those very large, powerful, large multimodal models that can take care of any task with zero shot or few shot examples in use cases that are very complicated that maybe a model does not exist for because our use case is very specific, or maybe again it is still not the time for the large models to handle that task very efficiently. We probably will end up fine-tuning a family of powerful open source models like Gemma for that specific use case. And yeah, as you said, we will probably see lots of such codes that are just importing one baseline model from Hugging Face, putting together a tokenizer, a model, and then maybe just use some LoRa and other schema, and then fine tune a couple of adapters for the task, and then in blinking of an eye, see how that model is applied to your own specific use cases. So I guess this is the new format of training that we are going to see at least for 1 or 2 years until we hit another checkpoint.
Yeah, I really agree, and it's a really interesting future.
Perfect. All right. Thank you very much. So I pause here. I promise you to present that one remaining paper the next time that we meet. Let me stop sharing. If you have anything to share as the last one, please go ahead. Otherwise, we probably can.
I'm not sure if you have the time for it. Do you have some 2 to 3 minutes
Yeah,
to
sure, sure. Let's go
your
to
final?
sure.
Uh, yeah, this was another blog post by Google, if I can find it. Yeah, this one, deciphering language processing in the human brain through LLM representations. And the overall gist here is that the embeddings of the Whisper model by OpenAI, and I'm not sure why they have used Whisper. I'm thinking they are Google research, but they have used the Whisper model by OpenAI, which is a speech-to-text model and has an encoder and decoder. And they found that the embeddings there correlate linearly with the neural activity of the Wernicke and Broca area in the brain, which is crazy. I mean, these models have come up with some representations that the evolution over millions of years have come up with. I'm not sure how that really came up to be, but yeah, this was the overall idea, and they have I mean, I'm not going to go in there in depth. Part of it is because I don't remember the details, but part of it is because we don't have time. And they show that whenever a person is listening to some speech, they went through the detailed neural processes by milliseconds, and then they found that the embeddings in the speech-to-text encoder are highly predictive of the neural activity in the area of the brain which is assumed, I mean, the Wernicke area, which is assumed to be related to understanding of speech, not to generate a speech, which is the task of the Broca area, which is depicted by blue colors here.
Yeah.
And they found that the decoder of the model, which produces text tokens, is basically doing, or the representations there, the embeddings there are linearly can predict the neural activity in the Broca area. So, and they also went through the reverse task when the human is generating speech, and they again found that the reverse process is also applicable, which I think is one of the greatest findings recently. And this line of research that is trying to find some common ground between how the deep learning models, the artificial neural models, could be related to the human brain, I think are really valuable. And just quickly mentioning a final blog post here of how the research in the stem cell therapies basically could be somehow related to AI. This is not something that this blog post is mentioning. This blog post is about how research could come up with spare human bodies that do not have any biologic neural networks. So they're basically just tissues, muscles, and other things other than the nervous system. And just considering that an artificial neural network could be integrated with this biological body and give access to the artificial neural network, the power to manipulate the world is just crazy. And how much more information that artificial neural network can gain via this way doesn't, it's not going to be bound to digital world anymore, to the internet anymore. It could just manipulates the data anywhere on Earth. So yeah, I just wanted to end up with this to just to provide some food for thought for the audience.
That is crazy. Okay. This is literally the best word, I believe. This is literally the best word. You just come up with somebody.
Yeah, I was exactly thinking of Westworld and basically the credits, the initial credits where the body was being made, and this is what they're trying to do.
Neural networks can be the brain. Oh, that's very interesting. Very, very interesting. All right. More exciting conversations to come. Thank you very much, Moin. I really appreciate it. Sorry for the time limits. And
Mm,
Yeah,
And
please.
yeah, we will talk soon and cover the rest of the topics.
Sure, sure, sure. Thank you very much. Have a good evening. Goodbye.
And have a good night, Share. Good night.
Thank you. Goodbye.